Okay, today's lesson was focusing on measures of variation, which is lesson 4-5. The student's mastery objective was that students will be able to use the median, quartiles, and interquartile range to determine if a set of data includes outliers. So looking at our first example, we're trying to determine if there are outliers. So we're looking at the data set, and the first step we need to do is to go ahead and organize the data, whether we're doing it from least to greatest or greatest to least. In this case, I organized it in the manner of least to greatest. Step number one is to go ahead and determine what our median is. So one strategy I can use is to eliminate our lowest, our highest, our lowest, our highest, and continuing the process until I can go ahead and identify what the middle or the median number is within our data set. And for this example, we have our median of 81. Now, in order for me to continue the process, I need to find the median of the upper portion of the data, or the upper 50%. So I'll go ahead and change colors for our purposes and continue the process. So again, I'm finding the median of the upper half of the data, which is our upper quartile. And since we have both 90s there, we would end up, if we have an even set of numbers, we would average those two numbers together or find the mean. Since 90 plus 90 divided by 2 is still going to equal 90, 90 becomes our upper quartile. Now I'll continue the process for the lower quartile. Again, we end up with 50 and 50. Now this is coincidence that we have 50 and 50 and then 90 and 90. That's not always going to be the case. But when you do run into such numbers as our 50 and our 50 here, we want to again find the mean of those two numbers. In this case, it equals 50. Now what we want to do on our next step is to go ahead and identify the interquartile range. And we're going to abbreviate that as our IQR. Our IQR will be defined or determined by the upper quartile subtracted by the lower quartile, or in this case, 90 minus 50. Using our computations, 90 minus 50, we'd get our interquartile range of 40. Now, I'm going to use the interquartile range to now determine if we have the existence of outliers. So what I'm going to do, in using our prior knowledge of outlier, or the interquartile range, and identifying the outliers, I'm going to take 40 and now multiply it by 1.5. 40 times 1.5 will give me a total of 60. It is this number that I am now going to add to my upper quartile and subtract from my lower quartile. $90 plus 60 equals 150, and 50 minus 60 equals negative 10. Using these new numbers, I'm now going to try to determine if there are outliers. The numbers of our 90 plus 60 equals 150 tells me there is an outlier if it is greater or equal to 150 within the data set. Examining our data set, I can see that there are no numbers that are equal to or greater than 150. On the opposite end, I'm going to use my negative 10 to determine if there's an outlier on the lower end. So if there are any numbers equal to or less than negative 10, then I'll have an outlier. Again, examining my data, I can see my lowest number is 25, which is not lower than negative 10. My highest number is 100, which is not greater than 150. Therefore, I have no outliers. Again, continue to feel free to review this slide and this short little video clip, and also your notes to help prepare you for our continuation of our curricular objectives.